Number 3. We did number 2. Smallest, so this time I'm looking for minimum. Smallest perimeter possible for a rectangle. Lost my place. Whose area is 16 square inches? What are the dimensions?
4 by 4.
Let's come up with some equations here. Sometimes I'll sit and think, okay, what was I given? Because I know I'm probably going to use that. But let's see what we have. We know we need to find perimeter, right? That's the one. Whoa. This is the one that I'm minimizing. Is that right? Yes. So perimeter is going to be 2L plus 2W. But the problem is I can't take the derivative the way it sits there to find the minimum, right? So what am I going to have to do? I need another equation. I'm going to use the area equation that was given. I know that the area is 16, and to find area, I do length times width, right? So solve for one of the variables. Which one? L. 16 over W. Everybody okay? I'm going to plug in here. So perimeter is really 16 over W plus 2W. 32 W negative 1 plus a W. My domain on this, by the way, is going to be from 0 to 16. I'm definitely not going to be able to go over 16, right? Because that's the area. So the perimeter, or the, well, I'm thinking about the domain of, I'm thinking about, not domain, but I'm thinking about what my W can go. It can't go past 16. Anyway, all right, take the derivative. Negative 32, W negative 2, plus 2. Yay or nay? Set equal to 0. Subtract 2. Divide by negative 32. Oh, we can do that. Like that. Multiplied. What? Oh, like you're saying, I see what you're saying. We did that like we did yesterday. You can do it, it doesn't matter. I just reckon, I'm not going to lie, I'll tell you what my brain did. My brain, as soon as I saw this, because this is just the way my brain works, I knew 32 divided by 2 was going to be 16, which is a perfect square, which I could take the square root of. I knew it was going to work out to be nice, so it was easier just to go through. But I see what you're saying, because we do need to find the places where the bottom, it might have a bottom going to. So we'll do it that way. We'll do it like we did yesterday. All right, so 32 over W2 plus 2 over, I'm going to make this W squared. 32 plus 2W squared over, is it, did I miss it? Yeah. This going to 0 is not going to impact anything, because it can't be 0, because I can't have a 0 width, because I wouldn't have a rectangle anymore, right? So, bleh. All right, so this 0 would be 2W squared equals 32, W squared equals 16, W equals, I don't need the negative side of 4 because I can't have a negative width. My derivative tells me what my function is doing at 4, and I'm only going between 0 and this will go up to, what did I say, 16? I'm going to assume negative positive. Is that right? If I plug into this. What'd you do? Did you do second derivative at P at 4? Oh. Well, because here's the thing, if it did this, here's my minimum, right? And in this case, it couldn't really be that, but it just, we have to make sure that we're finding the minimum or the maximum or whatever it is it's asking. Or maybe there was another break in here and this went up and then this went down and you have to know that that was the minimum. All right, so it looks like, and this isn't easy if W is 4. Now all the rest is pretty easy to find. And the length is also 4 because area is 16, right? If area is 16 and the width is 4, that means the length also has to be 4. It is a square, but a square is a rectangle. A rectangle is not always a square, so it fits, it works. So the area is 16. The perimeter would be 16 as well. What else? Okay, let's see. Show that among all rectangles with an 8-meter perimeter, the one with the largest area, all right, so this is what I'm optimizing, is a square. Length, width, width. So 2L plus 2W equals 8. Area equals length times width. So at some point, I'm assuming as we go through this, we will find that length equals width somewhere to know that it's a square, but let's see. I think that, or I know that we need to solve this for one of the variables, right? Which one did y'all solve for? L. Oh, too late. I already started solving for L. Sorry. 4. So area is 4 minus W times W. And then, right. No. This is a parabola like this, right? But we'll continue on with calculus. Actually, I didn't even have to distribute. Oh, I haven't taken a derivative yet. Now set it equal to 0. What does W equal? If W equals 2, what does the length equal? Right. Stop. 2. 0. To 8, I need to make sure that that is, what am I finding, the minimum or maximum? Max of area. Max of area. All right, between 0 and 2. Nope. I always have to write this so I remember. Derivative tells what the function is doing. So I'm plugging into the derivative. So if I plug in 1, I get 4 minus 2. 4 minus 2 is positive. That is that. 2 to 8, if I plug in 3, 4 minus 6 is negative. So that's that. So here is my maximum. So yes, W equals 2. If W equals 2, then that means length is 4 minus 2, which is also 2. Yes? If the width and the length are the same, it's a square. So it was worded a little bit different, but same thing. What else? No on 5? Y'all got 5.
Oh, yeah.
5 was the hard. What did I tell y'all to go through? 5 or 6? Hi, Lainey and Jaden. Pretend like this is on scale. All right. What are y'all fussing about?
Somebody in America can't.
Oh.
Somebody in America can't survive off of 40% of 30,000.
Yeah, y'all should.
That's what I did. I was talking
All right. Here we go. The figure show. Ooh. Y'all are so ugly to each other. The figure shows a rectangle inscribed in an isosceles right triangle whose hypotenuse is 2. All right, so let's unpack this for just a minute. A rectangle, so that means that this side is the same and then these side. Okay, so we're a rectangle. Inscribed in an isosceles right triangle. So that means that this is the same as this over here, right? These sides are the same. And by that I mean the whole side. All this is the same. Whose hypotenuse is 2 units long. Okay, we got that. Oh, excuse me. Express the y coordinates of P in terms of x. Write an equation for the line AB is your hint. And this is A. And this is B. All right, well, let's do what they told us. They first said, here's a hint, write an equation for the line. How am I going to do that? Let me ask you this. What does knowing that it's an isosceles right triangle have to do with anything? 2 sides are the same. What else do you know? Isosceles right. Okay, what else do you know? Keep going. Keep going. What do you know about the angles? 2 angles have to be the same. If the legs are the same, the base angles are the same. That's one of those geometry theorems, right? So I know this is a 45, 45, 90 triangle. Why is that special? There is an equation that goes with it. There's a thingy. You're right. Whatever the side length is, yes, it's x times the square root of 2. Oops. Yes, this is special right. Right. We're doing this in pre-cal right now because I told them y'all do not remember these triangles. Remember, this is what we used to form the unit circle when we made it in pre-cal, special right triangles. Yeah.
I agree with that.
Goodness. All right, so why is that important? That's important because, well, we might not even need it for this one. Let's see. That's okay. You need to know that. Shut up, Robert. This side is 1, which means this is what? 1. Agreed? What are the coordinates of point A? 1, 0. What are the coordinates of point B? B? B. 0, 1. Well, if it's an isosceles right triangle, oh, no, wait, no, 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 no.
That's right.
No, the isosceles part comes here. This is the isosceles triangle. Okay, so wait, that's okay. We can still know something. It used what? Okay, what system are you doing?
Like, couldn't you do, so you know, so like, can you do something? I'm pretty sure you could. Because A and B would equal each other.
I'm going to pull this triangle out for a second. This is the big triangle. This is 2 across the bottom. These are the same, which means this has to be 2 over the square root of 2. Right? Because this is an isosceles, right? It's a 45, 45, 90 triangle. Now if I bisect it, this angle is still 45, yes? Which means that this has to be 45 as well. So now I've got 1, 1. One over square root of 2 is not square root of 2. Where am I going wrong? Bro, this one's hard. This has to be 1 because this was a 45, 45, 90 triangle, right? We already said that. We established that. This has to drop down at 9 degrees because this is the origin, right? That's what it says. So this also has to be 45. So all the way across, what I'm trying to do is I'm trying to justify why this is 0, 1. Well, because if you started out with this 45, 45, 90 triangle, right? And this is the origin. The origin always makes 90 degrees. That's right. It doesn't have any choice but to be, because if this is still 45, it hasn't changed, and this is 90, it has to be. So that means that these sides are the same. Well, they've already told me that this side was 1. Well, that means this side also has to be 1. Okay. So now I have 2 points, and I can write an equation for that line. Do you agree? Okay. What's the slope? One minus 0 over 0 minus 1, so negative 1, right? And choose one of those points to write your equation on your line. So I'll choose this one. Y minus 0 equals slope times x minus 1. Negative x. There's my equation, right? So what did it say? Express the y coordinates of P in terms of x. Well, you just had the equation of the line. Any point on this line has the point x, y. Do you agree? On this line right here. So instead of putting y, what does y equal? Negative x plus 1. So that point is x, negative x plus 1. That's A. Does that make sense? It's kind of like whenever we have x, f of x, because that's the y. Same thing. I just put the f of x in there. Are y'all with me? It doesn't always make sense when I do it, that's for sure. Express the area of the rectangle in terms of x. Now that you have the y part, now I've got this rectangle, right? I've got this rectangle, and it says that this is x, and this is the same, so this is another x, right? So what's the width or the length across the bottom? Look at the picture, 2x, right? It's 2x all the way across the bottom. That was already given. Because look at how it sits here, right? And it says that this is x. So this length is x, but that's only half of it. So the other half is also x. So I'm talking about distance, I'm talking about absolute value, right? All right, so 2x across the bottom. Is everybody with me? Now the question is, I need the height or the width here of this rectangle. Well, height has to do with which coordinate? Y. It's now in half. You just found that point P. That's the point of this vertex right here. What was it? Right? So this is how far over, but remember I had to double it because of how it's situated. But how far up does it go? Well, it goes negative x plus 1 up. Does that make sense? It does, Robert. What makes sense about it?
Well, the rectangle.
You would literally just sit back there going, as you watch a video on your phone. All right. Triangle's up negative x plus 1. Does that make sense? Why is my height? All right. The vertex of the rectangle sits on the triangle, but we're really just looking for the triangle helps us to find that point, but it's not impacting, other than that, it's not impacting the rectangle. No, I found this point right here, this vertex. So what that point does is that point tells me how far to go over, which was x, and then it tells me how far to go over, which was my y, which was negative x plus 1. And that's where I use the triangle to find all that. All right, Brian. Okay, let's write an equation for the area, and then let's see what happens. Because part B asked me, express the area in terms of x. What would it be, Robert?
Well, 2x
times negative x plus 1. So my area is negative 2x squared plus 2x. Agreed or disagreed? Okay, that's what you had on your paper? Lies. Is that not what they got? They got what? Same thing, yes. You scared me. My stomach dropped a minute, Madison. All right, now we're on to what we've been doing with the optimization, which is what is the largest area the rectangle can have and what are its dimensions? Largest, I'm optimizing. I need to take a. No, not necessarily. We don't know that. Because it could be inscribed in here anyway. What if it was inscribed all the way up here? Or what if it was inscribed down here? What we're doing is we're finding the x. We're finding where this point needs to come to make sure that the area is the most it can have when it sits inside here. And it might come out to be that. That might be the solution. But what we're trying to find is which one makes the most sense. All right, so let's do derivative. Negative 4x plus dose. Where does that equal 0? 1/2. Robert! You did what Robert did. You're just randomly thinking about cutting it in half. Did you take a derivative, set it equal to 0, and come up with 1/2? Oh, that's fine. Robert did not take a derivative, right? Robert looked at the picture and said, oh, look, it goes over to 1. I'm going to pretend like this is 1/2 and see what happens. Because it looks like it cuts it in half. Right. Well, no, but listen, this is what I told Robert this morning. Assuming he got the units correct on this one, he would have gotten 1 out of 9 points for that. Yes. Because that's how much the answer itself is worth.
In the real world,
1 point for your answer, and that includes the units. Oh, no. The units go with the answer. Yeah. That's part of your answer point. Okay. Here we go. So positive, negative, up, down, right? So this is my maximum. Okay. This is my maximum. So, but that's still not what it asked me to do. It said, what's the largest area and what are the dimensions? Thank you. Oh, Avery, your brother's been worrying himself to death about this. His makeup pictures. Okay. He was telling everybody, but it's okay. All right. All right, look, 1/2. X is 1/2. That means that the dimensions of my rectangle, right? 1/2, 1/2. So all the way across the bottom, what's my rectangle? 1. But now I need to know what? This is not a P. This is my negative x plus 1, right? So what is that y coordinate there? If my x is 1/2, what is y? Also 1/2. So what are the dimensions of my rectangle? Well, that would be a 1 by 1/2, yes? And what's that area? 1/2. Largest area, 1/2, whatever my units. Dimensions are 1 by 1/2. Let's move along, yes. I'm going to give you some more to work through. See how it goes. And I'm going to be here to help you. We'll probably spend another at least day on this, maybe even longer. Robert Jenkins, you better take some derivatives on this one. You'd literally a 1/9 of the total points, or 54 total points. Multiple choice, you'd get 100 on that part because. I can't remember. No, he did do a lot. He was smart. But. I feel like I'm gonna need to do a couple of these with you.
Well, let's see. Go out to.
Which one did I try to do with you yesterday? And I was like, I think we could do it now.
No, don't do that. You never watched Star Wars? Have you watched Star
Let me make sure.
How do you do this? I got